This conference will now be recorded.
Okay, in this particular concepts we are going to be covering is like the complete backend based interview questions. Says that in various roles you can be able to apply and get cracked on that particular interviews. Okay, so from the synthesis, pre-STA, physical design, post STA, physical verification, Red Hawk related, all this particular questions, what all kind of questions can be answered, questions can be asked, we will be able to support you on that. Okay, coming from one by one. So if you have any input also, you can share it with me as well, so that we can be able to develop our skills more. Okay, and one point to be added here is like nowadays it's like changing, so they are expecting is like more practical based and very less theoretical based. Okay, on actual violations, what all you are observing, how we are fixing those particular violations, based on that only we are trying to come up in the interviews. Okay, that is in an advanced level. So when you go as a fresher or when you go as an 1 or 2 years of experience, we expect is like a basics of theoretical basics of practical knowledge and a good theoretical knowledge is what required. Okay, now, so the today's topic which we are going to be covering is synthesis and SDC files. Okay, I'll just start sharing my screen. Okay, any questions? Okay, so now coming to this particular concept, so synthesis. So first and foremost question is, what is the goal of synthesis?
Getting the gate level netlist from the RTL script.
Okay, anything else?
Yeah, with respect to timing constraint, we are optimizing RTL codes.
Right, and
PPA
as
improvement.
we discussing, we are going to be writing the answers also, because I prefer like doing that particular methodology. Yeah, go ahead. Someone is trying to answer.
Yeah, mapping to the respective technology, optimizing the RTL netlist and mapping to the respective technology, particular technology.
So that is what gate level netlist is, right?
Yes, yes, GLS, yes.
Yeah. So gate level netlist, when we are telling, that is like mapped with respect to the technology, or let's say libraries, and we are getting that particular gate level netlist. And the main criteria we say is like timing optimized netlist. Okay, so the goal of this particular synthesis stage is to provide gate level netlist to the PD engineer by considering, okay, by considering timing. So when we are telling timing optimized netlist, right? So which particular timing has to be optimized here? Setup or hold?
Both on a
So the
setup.
answer is, in synthesis stage, setup is what your major priority is. Okay, setup timing violations should be less than 100 ps, let's say. Okay, whenever we are going for one stage to another stage, we prefer of seeing that particular count and whether it can be optimized in the next stage or not. Okay, so that's why we give a target number of 100 ps. So in certain projects you will be seeing that a target of 200 ps also. Okay, so based on the clock period and based on the logic levels, we will be having this particular violation negative worst negative slag number getting decided. Okay, so second part is the grouping of, or let's say, congestion reduction. Okay, so there can be, the second step is congestion reduction also can be done in this particular synthesis stage. Okay, congestion reduction also can be performed in the synthesis stage, and a point to be noted here is like the runtime will increase. Okay, when you perform this particular congestion reduction, the runtime will increase. So details of that we will discuss in the next coming questions. Okay, and also power optimization. So this will be, as we know, is like in VLSI we have three major categories: timing, power, and area. So these three can be optimized in the synthesis stage as well. So instead of telling a one-line statement like we provide a gate level netlist to the PD engineer, we can say is like the netlist is timing based optimized. Okay, timing based optimized, where you don't need to tell about the remaining two. If you're telling about congestion, please give a priority only for which term you're using. Okay, timing based optimization and power optimized design. Okay, these are the first question. Next, what are the inputs for synthesis?
Libraries, RTL codes,
Okay,
SDC,
yes,
okay,
STC, yeah,
yeah,
power related
yes,
fields.
yeah,
power
if
related.
multi-voltage UPS,
Okay,
power intent UPF.
yeah, power intent UPF. Next, it's hang right now, so I've typed it. It will come a bit
Constraints.
later. SDC, UPF. Next,
Scan configuration file.
scan setup protocol. Anything else required? So first, before going to this particular question, I'll go to the fifth question and I will come back to this particular second question. Okay. So what are the different types of synthesis?
logic synthesis, power-aware synthesis,
Okay.
Physical
Next.
synthesis. Physical synthesis.
Right. So basically, we have these two categories of synthesis only: logical aware synthesis and physical aware synthesis. So according to the type of synthesis which we are using, the input section will vary. So now what is the difference between logical aware synthesis and physical aware synthesis? What is the difference between logical aware and physical aware synthesis?
Physical aware.
Right. So I'll write an input def file. Next,
left files,
def files. Next,
We can get the congestion number also in physical sense.
okay. Next. So let's go one by one. As you said, right? RTL codes, libraries, So in libraries itself, I'm going to be adding that particular lib and lef. Okay, next SDC, UPF, scan setup, def file, and as we are telling physical aware synthesis, that will be the technology based optimization. So I need one more in library, technology, that is TF plus TLUP. Sorry. Okay, RTL codes, your libraries, SDC, UPF, scan setup, def, and technology. Okay, according to the type. Now, which inputs is required for logical aware synthesis?
RTL codes, libraries, SDC, UPF.
Right. Next, scan setup. Okay.
Yes.
So this 5 files, except the left file, will be required for the logical aware synthesis. And the remaining, if you add the remaining files, left, def, and technology, you will be having it for the physical aware synthesis. Okay. Now, so can you guys explain me in brief, just say like 1 or 2 lines about RTL codes? What information is provided in the RTL code? And the second point is, if it is missed, let's say if it is missed, what will happen? Information present inside the RTL code.
A behavioral uh, information like structural information will be there.
Behavioral model of
Yes.
what? Of what? Of your
A particular logic
functionality, yeah,
functionality.
or design information. In one term, I can say it's like the RTL codes is going to give you that particular design information. That means your functionality information. And next point is number of modules, number of ports, number of instances. Okay, this kind of information is present inside the RTL code. Okay, and one more point is connections. Okay, so that it's a sub whatever we have written here, right? Design information, that design information is going to be having your number of modules, ports, instances, connections, pins, all that particular information is going to be present inside that RTL code. Okay, now one more question, let's say like a sub question of this particular input. Now, while performing synthesis, do you require only one RTL code to complete your design, or you will be taking off help of multiple RTL codes?
There will be multiple RTL codes.
Right. If, let's say, for example, in my main RTL code, I am having is in my main RTL code, let's say I'm having I'm having a module PD interview. Okay, in my main module VLSI Guru, I'm having is a sub module PD interview. So if this particular PD interview related, okay, if this particular PD interview related module is giving me a linking error, okay, if this particular PD interview is giving me a linking error, LNK-003 or 004 it will be having. If I'm having that particular linking error, then what is the solution?
This PD this is not instant. I think that module is missing.
Right. So the answer is it is instantiated, but the module definition is not provided. Okay, there is a sentence mismatch. That's what I'm trying to rectify there. Okay, so it is instantiated, but the module definition of this particular PD interview or in the file list which we have provided, it is missing. We need to add that particular file to resolve that particular linking errors. Okay, now so it's having our second answer itself, right? If that particular file is missed, okay, if a particular file is missed, then it will lead to linking errors, correct?
Yes.
Now what if that particular complete RTL code itself is incomplete, or you're finding empty modules, then what will happen? It might be a silly question only, but it also plays a major role. What will happen?
It will
Tool
appear
will
as black box.
Right, black box. Next, is there any use for me to run the task?
no.
No.
No. Right, so that's what. So if the RTL code itself is not provided to me, then there is no synthesis stage itself. That's why I said it's a silly answer only, but the way of thinking is different. You said like it's giving me a black box, but I'm simply saying is like there is no need of synthesis stage. Okay, so be frank.
Block box synthesis can be done, right? That some switches we can use.
Yes, yes. Black box, if you want to, let's say, I'll go ahead. There is one more concept for this particular black box. Automatically, the tool will try to remove this particular kind of empty modules if they are not connected to any of the instances. Let's say if that particular module is floating, the tool will just remove that. So to keep that particular black boxes also in your design, we need to enable few features before going into the optimization. Okay, those we can be modified by application variables, or yeah, majorly through application variables only we are going to be making sure that this particular black boxes will not be removed. Okay, now the second input which we have written is libraries. So what type of libraries are you going to be providing to your synthesis stage? Which
Flow,
extension of files you are going to be providing?
Standard cell
HUTLBT
library.
libraries.
slow process,
Sorry, slow process,
low
and
voltage,
I heard okay, low voltage,
high temp, low temperature.
Low temperature.
All
Okay,
variety of
so
libraries.
you are giving me is like PVT conditions for that particular library which needs to be selected, right? So I'm asking here is what are the libraries you are going to be providing to the synthesis stage,
Standard cell
Technology.
library.
right? Next,
macros,
next. There is one more special, or let's say there are two more special libraries called as synthetic library and the symbolic library as well. Okay, standard cell library, macro library, synthetic library, symbolic library. Okay, so now when you are using, okay, from now on I'm going to be talking only about physical aware synthesis because that is what most commonly we are going to be using it in the industry. Okay, so as we are going to be using physical aware synthesis, you are going to be providing the standard cell library information through which particular file.
.lib.
.lib. I'll give you combinations. .lib,
Okay.
.lib plus .lef, sorry, .lib, .db, and .ndm and .lef. Which particular I'll mention .lib
.lib and
or
.lib left.
or .db plus .mw or .ndm. It also needs DB files. So which particular set is required for providing the input files?
Yeah. .db plus .milky way file.
Right. So these two formats are correct. Sorry. These two formats are correct. That is .db. One second. Why this? .db plus .mw and .ndm plus .db. This both the files are correct.
Okay.
According to the tool methodology which you invoke, the input file will be changed.
Okay, something like that. For ICC one, it is MW Milky Way, and for ICC two is Indium.
Correct. That's correct. So here we have is like two methodologies. Okay. DC shell hyphen topo and DC NXT shell hyphen topo. Okay. DC shell hyphen topo is going to be supporting .db plus .mw. DC NXT shell hyphen topo is going to be supporting both the formats. Preferably we use this particular format, DC NXT shell hyphen topo. So similarly for this particular macro library also you're going to be providing the same. But when it is coming for the synthetic library, you are going to be using the files which is having the extension .sldb. .sldb files. Okay, we will just see about those particular files also. And next symbolic library is SYM. Now, what is the information? First, we'll go with .db. What is the information provided in the DB files? As one of our friends said already, PVT conditions. Next, logical library. What is the information present in the logical library? So when we are telling logical library, right? So you will be having is like major three terms again: timing, power, area related information. Okay, so you can just mention it's like timing information, power information, and area information. Only the logical values will be provided. Okay, inside the timing you will be having DRVs related information, and next setup time and hold time. Next is cell delay. Next is which model. Okay, so I'll ask a question in a different way. What is the purpose of WLM model?
Estimate estimate delay, sir.
Estimate delay for what?
Net delay.
Sorry, someone
Net
is
and
trying to give
interconnection delay.
Interconnection delay.
Net and
interconnection,
interconnection.
net delay. Anything else?
Estimate RC extraction value, sir.
Right. WLM model is present in the .lib or .db only to extract or estimate the RC values only. It is not used for calculating your net delay. WLM is a sub-model used for supporting values of RC values. Okay, whereas Elmore delay or Arnoldi delay will used for calculating your net delay.
Can
Okay,
you repeat
by
once
using,
more?
yeah, by using WLM only the RC extraction will be done. RC extraction or estimation is used with WLM model, and Elmore delay or Arnoldi delay will be used for net delay calculation. Okay, and this model, that is like Elmore delay or Arnoldi delay model, will require the input is RC values, that is your parasitic values. Okay, based on the technology node, it can have inductance also coming into picture. Okay, one by one parasitic gets added over here. RC, RLC, R, like that you will be having that particular based on the technology node. Okay, and this is common. WLM is used for your R parasitic extraction or parasitic estimation. And the next point is Elmore delay or Arnoldi delay only is used for your net delay calculation. Okay, with the values extracted from the WLM. Here, now what are the other timing information provided through .db?
Minimum width violation. Minimum width.
Minimum width. Okay, next. So here we have written setup time and hold time, right? So similarly, you will be having some terms called as recovery and removal also. Yes or no?
Yes, sir.
Sorry?
Yes, sir. Yes, sir.
Yeah, okay. So DRVs, setup time, hold time, cell delay, WLM model, recovery and removal. Okay, these are the timing information provided through the libraries, correct? And also you will be having DRV calculation tables. So all the information which we have written over here will be having a lookup table support only. Okay, a lookup table format will be provided for each and every calculation, delay calculation. Okay, now next is
DRV in the
power.
sense it is design rule violations you are talking about.
Yeah, that is like max trans, max cap related count.
Okay.
Max cannot.
Yeah, so that is like max transition. Okay, so now coming to this particular point, so max transition and max capacitance values will be provided in a single. Okay, and a point to be added here is the transition time near to a pin will be calculated. Okay, max transition supportable by that particular pin will be provided, and also there will be one lookup table which is going to be calculating the transition time at that particular instance of time. Okay, now what are the different power informations you will be finding in the lib?
Leakage power.
Internal power
Leakage power and internal power.
switching.
Okay, right, so major these two terms is what we will be finding. Now this particular internal power will be calculated based on the switching activity of the pin. Okay, again a lookup table will be provided for this particular internal power calculation as well. Okay, and leakage power also, based on the inputs which you have provided, you will be finding the small lookup table for that. So each and every value which you are finding in the .db, you will be having a lookup table. Okay, except for the terms pvt conditions, max transition, max capacitance and area. Okay, area will not have any lookup table, that is constant. Okay, and the next information you will be finding here is for each and every cell there will be a functionality information provided. So how a functionality information is provided in the .db file? Any guesses?
Yes, like if we take inverter, like if we are giving input 0, so it should functionality like 1, right? Output like that.
Yeah. So if I'm giving a rise transition, the output is a fall transition. From the .lib, how we are going to be getting that information? So you have a term called as uniqueness, right?
Yes,
Heard about this uniqueness? So
yes,
this
Yes,
positive.
sir.
particular,
Yes,
right, this uniqueness is going to be giving you the functionality information of your cell. Okay, that means if I'm giving for an inverter a rise transition, then the output is a fall transition. So which type of unitness it belongs to?
Negative
Positive unitness.
Negative unit.
Negative unit. So similarly, if I'm having a buffer, which type of unitness it belongs to?
Positive.
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 If I'm having a NOR gate, then which particular unitness it is belonging to?
Ununitness.
Non-unit.
NOR unit. Perfect. So that's why what you have to prefer here is, if I'm having in your timing report, you will be seeing input pin, output pin, and some delay value, and along with that rise, fall, these keywords you will be seeing in your timing report. Okay, this rise or fall is going, or let's say these values are extracted from the cell library uniqueness. Okay, it is a rise transition, it is a fall transition. So which type of uniqueness it is belonging to, all that is extracted from this particular uniqueness category only. Okay, now if this particular library is missed, let's say as we have written common for your macro and standard cell, if this particular library is missed, what will happen? If a particular library is missed, what will happen? It
Resolved
has the same
reference error.
information of, sorry, go ahead.
Unresolved reference error.
Resolve the reference.
Yeah.
Perfect. So I'll just say here like linking errors, okay, or unresolved references. Okay, so how to resolve it, we will see in the next steps. But first is like we'll just look what all errors are there. Okay, next. What is synthetic library? Anyone heard about this?
Technology independent
Design by
Right. So synthetic libraries are, first one, technology independent libraries. Okay, first point is there are technology independent. So why I'm telling these are technology independent is, synthetic libraries are provided by the tool vendor itself. These are provided by the tool vendor itself. Okay, now as there are tool vendor providers, so it is technology independent, or let's say it will be a global file only. Now the information of the cells which it contains is designware components. Okay, it contains designware components. So initially that will be like DW star. Okay, DW star related cells information will be provided through this particular synthetic library. Okay, later on this particular synthetic library has to be linked with respect to the technology library during the optimization and mapping stages. Okay, clear? Now, yeah, go ahead.
In synthetic library, actually, it contains same like logic gates or other gates.
It will be having a like macros related instances.
Okay.
The basic logic gates, we won't find it in the designware components. So which is having a complex circuitry only, we will be using this designware components. It is to the designer whether he want to use it or not. It is not compulsory that you will have it. It is up to the designer.
Okay.
If he wants to use it, he can use it, or else he can skip that. Okay. Now, let's say for example, I want a particular macro, and that particular macro is taking some time to develop. Let's say he needs downtime of 2 months to get it developed, and I don't want my project to be stopped. So what I will do here is find an equivalent macro which is globally used, and I will try to use the optimization methods. That is like I'll take the help of the designware components. Later on, I will swap that particular designware components to the real macro once it is developed. Okay,
Okay.
right. Next is symbolic library. From the term, can anyone tell me what a symbolic library means?
Symbolic representation of the cells or my cells.
Right. Schematic representation of the cells. Okay, so when we are trying to see the schematic for buffer, what is the structure, how it is looks? A
Triangular.
triangle shape, right? And next is like inverter, a bubble added, and gate, or gate, nor gate, like that we are having this representatives known to us, and those equivalent representations will be provided using this particular symbolic library. Okay, and again it is provided by tool vendor itself. Okay, clear for everyone so far?
Yes.
Right.
Normally, these libraries will provide normal libraries characterization team, right?
Yes, correct. Standard cell team, we can say.
Mhm.
Okay, so if there are, okay, if you want to add any new gates, right, so those particular new gates has to be appended to its equivalent variables of the symbolic library. So each and every library which we have discussed here, right, it will be having each and
Your voice is
every
not
library
audible.
separate. So let's say for standard cell team there will be a separate team, and for macro there will be a separate team. Okay, and for this particular synthetic library and symbolic library, the tool vendor itself is going to be taking care of. Okay, you can say it as a macro library or memory also. Okay, based on few companies they will be changing their term memory or macro. So in
Does it
here
mean
the
all macros are memory? It sounds like that, right?
no, no, it's not like that.
Okay.
All macros are not memories. Okay.
Vice versa
Now,
is correct, right? All memories are macros.
yes, correct.
Okay.
Just trying to get this. Oh, sorry. One second. Okay. Now, the next input which we are going to be discussing is NDM. Oh, sorry. We'll just go like first is dot MW. What are dot MW files is going to be having?
Milky Way.
Yeah, it is a Milky Way database. What information is going to be present inside that Milky Way database? So, as I want to load the left file, right? So, as you have done in PDs, most probably, I think so. In PD, did you load the left file
Yes.
manually
No, no, sir.
No, it is
with the
contents and
help
load.
of right with the help of NDMs? You
NDM
have
format.
loaded the left files into the design. So similarly, in synthesis also, we don't have a supporting command to load that particular physical library into the tool. Okay, only the left files to load. I don't have an information. So indirect methodology, I'm going to be using it over here. Okay, indirect methodology. That means I'm going to take Milky Way database files for loading this particular physical libraries information. Okay, indirect methodology. That means MW is not going to be having only the left information. It is going to be having your complete design information. Okay, the complete structural information is stored inside this particular Milky Way database file. Okay, you can load this particular Milky Way database and you can see that particular information also. Okay, complete information of the design or cell according to level which you are going to be saving here, right? MW. So that's why I said it's like design or cell. It can be a macro or a standard cell or your block that can be saved as MW as well. Okay, and the only drawback of this particular MW is it doesn't store any kind of timing information. Okay, any kind of timing information will be not stored in this particular MW. We need to provide it again and again and again every time when we load this. That is the one drawback of this particular Milky Way database. Okay, next is NDM.
One quick question here. In Cadence environment, we are not going to use Milky Way, right?
Yeah, correct. We are not going to use Milky Way.
Only
We
NDM
have
will
it.
be used.
Yeah, we use this like most probably. Let's say like in Synopsys, you're going to be using .db files. But
Okay.
in Cadence, you are going to be using is .lib files.
Yeah, yeah.
Okay. So like that, there will be a small variation between the tools.
Okay.
Now, coming to the next is NDM. Okay, what does this NDM will be having?
Live and live file.
Yeah, so this has a small difference. So this NDM, whichever is developed by one of a library manager tool, okay, it's a developed by library manager tool only, and it is going to be having the technology information, the logical library information, and left information. So this particular physical information can be either provided through left GDS or OSS. Okay, so according to the level of the project which you are going to be working, this NDM is also going to be varied. Okay, this 3 is compulsory, or let's say this 2 is compulsory, but according to the project, or sorry, according to the level of the project, you are going to be changing the NDM. That means, like, if I'm going to be performing synthesis and PNR, for a faster processing, I will use this TF, lib, and lef files. Okay, so when I'm going to be performing physical verification, right? When I'm going to be performing physical verification, I need the help of GDS or OSS files plus lib and technology file. This is compulsory change. Okay, so all the base level information and the top level information is stored inside the GDS files. Okay, physical information variations, we can say. Okay, and this particular NDM will be having same the complete design information. Okay, complete design information will be present inside this particular NDM. And the advantage is it is a compressed file. It cannot be corrupted. Okay, it is a compressed file. It cannot be corrupted. That's what we are going to be using NDMs in an high priority. Okay, and it is also going to be having, as you can see, lib information is also stored. That means timing information is also stored inside this particular NDM itself. If just by directly loading this NDM, the complete information of the cell or design is loaded. Okay, no need of providing technology. Compressed file cannot be hacked. Okay, until and unless you have permissions and you delete some ASCII characters, then we cannot do anything. Okay, it cannot be hacked easily as MW. If in MW is like each and every information of the design, physical information also, will be stored in different files. If one file is removed, you have to redo that particular Milky Way. As here it's a compressed format, we don't have any issues. Okay, inside one directory only, it will try to save all the information, and you cannot be able to edit that information also, because it's an ASCII characters. Okay, clear so far for everyone?
Yes, yes, clear.
Right.
Yes.
The next is left file. What is the information present in the left file?
Abstract view of the cell.
Abstract view of the cell. Next.
Which metal layer used inside the cell. Metal layer
Okay.
used.
Screen information of metal layer.
Physical dimension. Cells.
In terminals. Metal layer. Oh, sorry. Okay. Next. Physical
And
dimensions. Next.
Orientations.
Metal layer.
Supportable orientations.
Blockages.
To be more specific, I'll mention like routing blockages. If it's a macro, then you will be finding this routing blockages most preferably. For standard cells, there will also be routing blockage, but less.
Antenna information.
antenna rule.
Right. Okay. Okay, so in left file, the first and foremost information you will be finding is like your cell dimensions, and inside that particular cell, okay, there will be information related to for each and every pin, the terminal. Okay, terminal information will be provided. Okay, it pin, and inside pin there will be a terminal, and for that particular terminal which metal layer to be used and its dimensions. Okay, metal layer and its dimensions. Now there are two types of left files. One is dot left, and the second format is technology left. Okay, or you can say mention it as like dot tech left. Okay, there are two formats of this particular left file. So if left file means it is going to be having only the physical information of that particular cell or design or standard cell, whatever it is. Okay, when it comes to tech left, you will be having one more extra input, that is technology information. Okay, what all information you are going to be providing through the technology file for the metal layers, those informations you will be finding inside this particular tech left also. That is the only difference between tech left and the left. Okay, that is M1, what is the min spacing, min width, structure information, manufacturing information, all that whatever you are providing in the technology file, that will be provided in the tech left also. Okay, Cadence will be supporting this tech left. Even Synopsys also supported, but we don't use that with an high priority because we always prefer of providing technology file separately. Okay, clear for everyone? Any questions, any doubts? Okay, if the left file is missed, what will happen?
Linking error.
Next, I've provided all the .libs, or let's say .dbs, but I have missed the physical information. The reference libraries I missed providing the particular macro. Now what is the error I will be able to see?
So it will throw the error like this.
Unresolved.
First concept is like, okay, physical aware synthesis cannot be done. Okay, your logical aware synthesis can be done, but physical aware synthesis cannot be executed. No unresolved references, you will not get any errors related to unresolved references, linking errors, anything. Okay, so you will be getting a direct point is like, first point is physical aware synthesis cannot be executed, and the second point is at which stage it will stop is during the compilation it will stop. Okay, during the compilation only the tool will stop this particular process. That means during the optimization the tool will stop, it won't execute further. Clear?
Clear.
So why I'm saying is like you are not going to be having unresolved references or linking errors. The reason is because I given one statement. All the logical libraries information is provided, right? So that means each and every instance module information is provided. So the only part pending is physical information. So physical information is just an external support for the optimization. So as that is not provided, your optimization will not go. Okay. So the next point is, what is the flow of synthesis?
Analyze,
Okay.
elaborate, and compile.
Analyze, elaborate,
And compile.
and compile. Okay. So now what we are going to be doing in the analyze stage?
Check the syntax
Checking the syntax. Next.
and generate the intermediate files.
Right. Generating the intermediate files. So in this particular synthesis flow, okay, there will be a separate temp directory created. Okay, there will be a separate temporary directory created. So what it is going to do is, for your provided design, okay, in that particular temp directory, what we are going to do is, for the run which we are going to be performing, we will store all the intermediate files into that particular temp directory. If that particular temp directory is removed, the next process cannot be executed. Okay, if any one of the intermediate file is missing, we cannot execute the next process. Okay, in simple terms, what the tool is going to do is, it is going to divide and conquer. Okay, your design is going to be divided into sub files, okay, into some PVL files, SYN files, like that. You will be seeing some extensions in the temp directory. So if that particular information is missed, so design will not be able to link that particular information properly. Okay, so don't touch that particular temp files. Okay, until and unless you, let's say your run is completed, the complete synthesis flow is completed. If you don't need it, you can remove them. If the process is not completed, don't remove them. That's what is my suggestion. Okay, now here in the analyze stage, we are going to be checking for the syntax only. Okay, we are going to be checking for the syntax only. No elaboration, nothing is going to be performed over here. Okay, whether that particular code, whatever we have written, is following the RTL syntax and it is supportable by the tool or not. That is what we are going to be checking here. Okay, unassigned to assigned, assigned to unassigned, like that particular warnings. And if there are any modules called as, there are some modules called as generate modules, which is for your flip-flop supporting, whether those particular generate modules whichever we have used in the RTL code is supportable or not. Okay, those particular syntax only we are going to be checking in the analyze stage, no other. Okay, generating the intermediate files for further processing. Okay, next is elaborate stage. What we are going to do in the elaborate stage?
Convert behavioral code into the GTEC format.
Okay, next, while converting, what it is going to do?
It will bring all lower level
Assign,
blocks into the synthesis tool.
Right.
uh,
Okay, linking all
assign,
the blocks to good.
if assign is y is equal to a, this type, the add is used as a buffer, at the rate, always at the rate as a sequential cell.
right? So that's what you said, right? Those particular behavioral code, it is converted to the GTEC format, first point. While converting it, it is also performing one more task. I heard one more concept, that is like linking all the cells to the tool. That is not the correct term. Linking each and every instance to the equivalent module information. Okay. First step is converting, or let's say there are in parallel running, you can say, converting the behavioral code to the GTEC format. Okay, while converting this particular code to the GTEC, it also checks for the linking. Okay, linking of instances to the module definitions. So as we were telling earlier, right, if that particular module information is not provided, linking errors will produce. Okay, during this elaborate stage only, those particular linking errors will be processed. Okay, or let's say those errors will be created. Okay, now what is GTEC format?
It will contain basic logic gates and flip-flops.
Right,
It's a
so in the
technology independent format.
perfect. So
Yeah.
GTEC are technology independent and provided by
Tool provided by tool.
Erise, provided by the tool vendor itself. Okay, as this is an intermediate stage file, it can be understandable only by the synopsis tools. Okay, but not supportable by the cadence. Cadence has a very different flow compared to the synopsis. Okay, the main agenda is same, but the way of they represent or the way they execute the flow will be having a difference. Okay, so the flow is analyze, elaborate, compile. Throughout the different tools, the process is same, but the way of the command execution only will be having a difference. Okay, now linking the instances to the equivalent module definitions. If there are any missing, the next stage cannot be performed.
So
Okay,
one
GTEC,
basic question here. Instance count and gate count are same or different?
there are different.
Different.
So yeah, so instance count means basically the cell count we say. Okay,
Cell count.
whatever the
Okay.
cell count. Okay, but
Okay.
when it comes to the gate count, it has to be converted. That means the R instances has to be converted to NAND gate or NOR gate, which is like universal gates. And those particular count is what we will be calling it as gate count.
Okay. Instance count is cell count only.
Yes.
Okay.
But gate count is converted of that particular instance to the equivalent NAND gate representations or NOR gate representations, and those particular count in what we get is called as gate count.
Okay.
Okay, coming to the next step, that is compile. Okay, so what we are going to do in the compile stage?
Technology mapping.
Mapping and optimization.
Mapping plus optimization. Okay, so yeah, technology mapping, or I'll just keep a keyword like mapping and optimization is going to be performed. Okay, so now there is a sub question. Okay, you can say this as a sub question also. To perform this particular elaborate stage, Okay, do we need to provide logical library information?
Mm,
Perform the
Yes,
elaborate
requires
step.
If
If it is not provided, then what will happen?
for optimization, you can
not
provide logical libraries too.
no mapping is not happen, sir, because
In elaborate stage, if you see here, we are saying is like my behavioral code is converted to a GTEC format. That means an expectation is like the global.db is enough. That means the global library which is provided by the tool vendor is enough for my elaborate stage. I'm not doing any other optimization there, right?
Yeah.
So there are now one more term to be added. There will be some hard code instances. Okay, so that means I'm trying to use a module, or let's say a macro, which I bought it from you. Okay, I bought it from you, a particular macro, and I'm using that particular macro in my RTL code. Right now, what will this particular elaborate stage will try to do if I don't provide that particular library which I bought it from you?
Mapping will fail actually.
Linking will fail.
Okay.
Okay, to be specific term, linking will fail. So that's why if there are any hard code instances available in your RTL code, those equivalent libraries has to be provided. Okay, if there are no hard coded, then it's fine. Elaborate will pass. By converting each and every instances to your RTL global files, it will be able to map it or link it. Okay, but during the compile stage, it is compulsory to be providing the logical libraries. If you are performing physical libraries, the physical library also has to be provided. Okay, during the compile stage, it is a compulsory factor that, as one of our friends said already, that is like the mapping will fail if the logical libraries is not provided. If physical aware synthesis, physical libraries is not provided, that will fail as well. Okay, clear? Can I move to the next step?
Yes.
Excuse me, sir.
Yes.
Sir, at what stage clock getting cell and inserted, sir?
Optimization stage. So there will be some clock getters which is provided through the RTL code, and also during the optimization stage, that is in the compile stage, you will be having this particular ICGs getting inserted.
Okay. Okay.
So we are telling here optimization, right? In this particular optimization, with an high priority, your timing based optimization is going to be performed. And also, okay, and also it will also try to insert any level shifters it is missed. So if you are provided UPF file which a multi-voltage design, it will try to map all that particular level shifters, isolation cells, power switches, everything it will try to perform here. Our optimization will also be executed over here.
Sir, I have one question.
Good.
Sir, for writing UPF, so we need like level shifter, retention, and also. So we will get from synthesis guy only.
No, see, you're developing an UPF file. That means the power reduction technique, it's a separate technique used for your dynamic power consumption.
Yes.
That means the voltage control information you need to provide first.
Okay.
That means you need to know is architectural information of the design.
Okay.
Which particular module is going to be working at which voltage, and power any domain is going to be turned off or turned on. This ICG information, everything you can be able to get to know only by using this UPF file,
Okay.
architectural information.
Yeah.
Okay.
Okay.
So this we have already covered. Fifth question. So now, what is the difference between compile and compile ultra?
Maybe extra optimization, extra runtime.
Right. Next. Anything else? I'll just randomly select some columns. Compile, compile ultra. So first point is compile is supportable in logical aware synthesis. Okay. The next point is compile ultra is supportable in physical aware synthesis. Okay. When we are telling about compile, it performs in graphical based optimization. Okay, it performs graphical based optimization, and here it will try to perform in topographical based optimization. Okay, the next point here is in compile, accuracy for the optimization is approximated, or we can say it is less, and accuracy is high. And here, as it's a logical aware synthesis, congestion reduction cannot be performed. Whereas here, congestion reduction can be performed.
Because we are providing physical information, right?
Yes, correct. So as we are providing the def files and all, right, and also by enabling a particular variable, we can be able to perform that particular congestion reduction as well. Okay. And
Topographical based optimization means what?
yeah, I'll tell you that.
Okay.
I think. Okay. Runtime is less, runtime is more, and tool invocation also I'll give you that. Most of you have known DC shell. Here you are going to be using is this is what we were discussing earlier, DC NXT shell and topo for physical aware synthesis. Or in
Earlier you mentioned like generally we won't prefer this physical aware synthesis, right?
logical aware synthesis.
Okay, logical aware is done at a lesser rate than compared to physical.
Yes, we don't prefer this. Whereas we prefer is this physical aware. Okay. Now, so here I have written two different methods, right? Graphical based optimization and topographical based optimization. So in this particular graphical, or let's say topographical, the major difference is during this particular logical aware synthesis, the tool is going to be performing each and every cell placement virtually. Okay, whether it is graphical or topographical, the tool is going to be placing those particular cells virtually. That means in the compile, that is logical aware synthesis, every cell placement is approximated. Okay, first step is virtual placement, and the second step is approximated placement will be there. That means it might sit in a far location or it might sit in a closer location. We don't have an accuracy because macros also will be placed by its own, okay, in logical aware. So that's why I said is like here the accuracy level is very less. Okay, a more number of cells might get added for this particular compile. Okay, now coming to this particular compile ultra stage, it uses the similar algorithm of your physical design placement algorithm. Okay, whatever the algorithm which you are using for your placement stage in the PNR flow, the similar algorithm what this particular physical aware synthesis is going to be using. Okay, as the area is provided and macro placement is provided, the accuracy level will be increased. Okay, the timing, or let's say the cell placement, will be more or less same as that particular placement stage. Okay, in this particular compile, global placement of the cells will be done. Okay, it's like global placement, and in this particular compile ultra stage, it will perform the standard cell placement with the help of bounds. Well, that is like virtual bounds, all that particular concepts it will try to do it, and it will try to place the cells. Okay, from compile to compile ultra, there will be an number of cell count also difference. We cannot compile this, sorry, we cannot control this particular compile, and we can control this particular compile in different terms. Okay, purely approximated placement is going to be performed in this particular compile, and in topographical mode there will be an approximation plus known placement. That is like macros are placed and we know those particular placement, but this particular standard cells and everything, that is what majorly plays a role for us. Okay, it uses the algorithm of that particular placement stage.
It's
Any
mainly
question?
related to placement and area utilization.
Yes, correct,
Yeah.
because we know those particular factors here, so it uses that particular optimization method accordingly.
Oh,
Oh, sorry.
Placed in the sense it is just about interconnection, right? Not actually physical placement. You're telling.
Yeah, it is virtual placement only.
Okay.
Based on the pin-to-pin connections and the distance, it will try to decide it and place it closer itself rather than placing it in a far locations.
Okay.
Okay, right. Any other questions? Okay. So coming to the next question, that is steps performed in the compile ultra stage. That is like you said, right? Mapping and optimization is going to be performed in the compile stage, right? So what are the steps, how it is executed? What all optimization is done inside this particular compile? I'll try is the question. So first step is mapping. Okay, first step is always mapping. Next, the optimization starts. Okay, once this particular, during this particular optimization stage, the tool has an high priority for the timing based optimization only. Okay, in timing based optimization, okay, which particular optimization is done first? Let's
DRVs.
say, yeah, perfect. DRVs will be optimized, and next comes setup slack or hold slack.
Setup.
Setup slack optimization. Do I perform hold slack optimization in the synthesis stage?
No, sir.
Okay, I think so. I have questioned that in the next coming. We'll see that. Okay, setup slack optimization, and after that, okay, you will be finding our intent related optimization. It actually runs inbuilt itself. There you will not be seeing like a separate stage itself. Power intent related optimization will also be performed, and there will be one more step. Okay, okay, here we have is like, yeah, okay, and one more thing is like during this particular optimization, the tool will try to merge some of the cells, removes redundant, okay, removes redundant registers, or you can say redundant modules, all that it is going to be removing it, redundant cells, removes empty modules, groups the cells, ungroup the cells.
Boundary optimization.
Perfect. Okay, so
Retiming.
yeah, so that all done in the setup slack optimization itself. So that's why I haven't done separately like retiming. Now here we are saying is like removes unmodule and removes empty modules, right? Redundant and empty modules. So what the tool will try to do is first is like it will ungroup that particular modules. If any restrictions is not provided, the tool will try to ungroup that particular module, merge that particular cells, and it will remove the unwanted cells. Okay, whether it is compile or compile ultra, it will try to perform this ungrouping, and grouping will be performed in this particular optimization stage itself. Okay, so here I'll make it like ungrouping modules, grouping the modules to be more specific, and it
Sir,
will also, yeah, go ahead.
it's called as logical restructure, sir.
Logical, yeah, logical
Restructure.
restructuring will happen. Yeah, okay, that without changing the functionality. Okay, without changing the functionality, the tool will try to reduce that particular count variation. So let's say there will be sometimes what will happen is like the same definition, or let's say the same functionality is found parallelly. redundant. So it will try to remove that particular redundant case, where it will increase the fan out. That kind of possible cases will come. Group the cells to the multi-bit registers. Okay, so the tool will try to perform during the optimization stage. DRV is setup slack optimization. The order is changed. Okay, I'm not giving you the correct order. The order is changed, but this all process is done internal to that particular optimization stage only. Okay, clear? So these are the different steps done internal to the optimization stage. You can say logical restructuring, or it will also perform HFNS. So that is also performing a logical restructuring methodology itself. Okay, this question we have already answered. So at which particular stage of the synthesis do we have power optimization performed?
Optimization stage.
During the, to be specific, is like, I'll just say is like during the compile stage,
Yes.
and to be more specific, that is optimization stage. During the optimization of the compile stage, we have this particular power optimization getting performed. Okay, now do we have scan chain inserted in the synthesis flow?
Yes.
Yes. So what are the required modules for the scan chain insertion to be present in the RTL? Okay, so before going into
Scan
that,
related
I'll ask
information.
you a question.
Okay.
What is scan chain? What is a scan chain?
Scan registers lad
Okay,
to check the functionality.
to check the functionality. Next. Okay, so I'll just make it in a simple term. It's a back-to-back flop connected. Okay, scan chains are back-to-back flop connected. That is Q to
For the
SI
DFT.
connection. Yes, it is provided by the DFT. Okay, scan chains are back-to-back connected flip-flops, which is having Q to SI connectivity. Okay, it is not only the scan registers. A normal flip-flop can also be a scan registers if the SC is enabled. Okay, if SC pin is enabled, we can say it is working in the scan. Basically, a flip-flop will be having D, SI, SE, CLK, sorry, CLK, Q pin, Q bar, reset pin, clear pin, all that it will be having. If this particular SC pin is tied to 1, okay, if it is tied to 1, then this particular flip-flop is going to be working in the scan mode. Okay, then this particular scan chain, or let's say this particular connectivity, will playing a role. Q to SI connectivity will be playing a role, and Q to D will not be checked. Okay, that's why we say it's like two different modes: test mode and sorry, scan mode and a functional mode. So this is what we are discussing is like now scan mode. Okay, Q to SI functionality check will be performed. So this Q to SI connectivity information is provided through the scan chain. Okay, now if I want to test this particular functionality, okay, now which particular module is required? How do you check the functionality? DFT modules, which module is used?
Functional mode? No.
No. DFT modules.
Yeah, test mode, scan mode, some mode.
Yeah, those are mode namings. So for functionality check for the DFT people, right? There will be some modules. Sorry, my bad. There will be some modules which is going to be having. Those are like, if you heard like some keywords like stuck at 0, stuck at 1,
ATP.
ATPG, JTAG. So those related code generation, the vector code generation has to be processed internally itself, right? Test vectors are created internally only. So those particular modules has to be present inside the RTL. Okay. So I'll just mention like DFT modules like your ATPG or JTAG or so and so. Okay. Or you can say it's like BIST related modules, LBIST, MBIST, like that you will be having more terms coming into picture. Okay, those particular module informations has to be present inside the RTL code. Then only you can perform this scan chain based optimization. Okay, or your scan chains can be inserted. If this particular modules are not present, then there is no use of inserting the scan chain. Okay, clear? Now, the question is, at which particular stage do you have this particular scan chain getting inserted?
Before
Placement.
optimization.
Before optimization. Next.
After synthesis, so they will do like.
Okay, so the steps are like, during the optimization, okay, during the optimization we have this particular scan chain getting inserted. Okay, so that means we have provided one input, right? Scan setup.tickle, that will be having the configuration information of the scan chain. Okay, in one scan chain, how many flip-flops to be present, what all connectivity is present, that is provided through that particular scan setup.tickle file. Okay, scan chain configuration information is provided through the scan setup.tickle. Okay, now the next step is, during the optimization this scan chain gets inserted. To be more specific, right, during the incremental optimization, okay, during the incremental optimization this particular scan chain gets inserted. Okay, that means first run I'll try to perform analyze, elaborate, compile, ultra. Okay, analyze, elaborate and compile, ultra. Okay, and after that I will provide the scan setup.tickle and provide compile ultra hyphen incremental. Okay, that is like, the steps are like, first is analyze, elaborate, compile ultra, next scan setup.tickle, and next is compile ultra hyphen incremental. And in this we have some supportable switches like hyphen scan also. Okay, so these are the steps performed. So first step, or let's say first three steps, you will be having one gate level netlist. Okay, And the second step, we will be having another gate level netlist, okay, to make sure that this particular scan insertion is not disturbing any kind of functional connections, to verify that we have different netlist extracted. Okay, clear? Any questions, any doubts?
No, it's clear.
Okay. Now, before going into the 11th question, I'll go to the 12th question and come back to the 11th. So, what are the files you are going to be generating from the synthesis stage?
Gate level netlist.
Netlist, SDC files, UPF files, scanf files.
DF files
Next.
and inserted SDC, scan inserted netlist.
Yeah. So let's say after compile ultra, it will be without scan inserted. And if you are executing after compile ultra with the scan chain, it will be having scan inserted netlist. So you can say is like when you are telling about gate level netlist, there are two formats: with power pins, without power pins, or let's say with power connectivity and without power connectivity. Okay. Now SDC, UPF, ScanDef, and there is also one more file you will generate that is called as DDC file. Okay, I don't know the full form of it. Okay, it's a DDC file. So we'll go one by one. Now you will pass. Will you pass this gate level netlist to the PD engineer?
Yes, sir. Pass.
Right. It is passed to the PD engineer. So will this SDC file be passed to the PD engineer?
No, sir.
Why no?
Yes.
Because this generated for only synthesis purpose.
No, it's not like that. Okay, so what happens is, to mask some violations, you will be adding some extra commands. Okay, rather than the information provided from the main architectural SDC, you will add some extra commands during the synthesis to mask some violations. Okay, and when you extract it from the tool, it will have that particular masked violation commands also, which should not be provided to the PD engineer. Okay, it contains, as I'll make it like, as it contains extra commands to mask the violations observed in the synthesis stage and can be fixed in the PD. Okay, to mask the violations observed in the synthesis stage, but it can be fixed in the PD. We don't want that particular commands to be provided to the PD engineer. So that's why you will not provide the synthesis SDC to the PD engineer. Okay, so the extra commands are like, for example, set path margin. Okay, and also, okay, this is used for masking, and also you will be having is like set lock uncertainty variation. Okay, the group paths, path grouping. Okay, weightage difference will be observed from your synthesis to the PNR. Okay, weightage, can be different for group path from synthesis to PNR. Okay, so that's why this command also gets added in the SDC file. So to avoid them, we will try to not provide this particular SDC to the PD engineer. Clear now?
It is not passed to the PD engine, but PNR SEC file is required, right, sir?
Yes. So I'm mentioning, like, to be specific, synthesis.sdc will not be provided. So there will be one SDC, let's say like central directory SDC. From that particular central directory only the SDC will be picked for synthesis or for PNR.
Okay, okay.
Okay, which will be having uh, which will not have this particular extra commands which we have masked the violations. Whatever the original content is there, that particular content has to be followed. So that's why we will try to avoid this kind of commands, intermediate passing of files. So will this be passed, UPF file be passed to the PD engineer?
Yes, sir. Pass.
And the file,
UPF file, there is no optimization will be done, right?
UPF
Just
file,
input file.
initially what will happen is they will try to give you with the RTL code. Okay,
Okay.
RTL naming, structuring, everything will be provided, shared to you. So the next is like there will be some optimization happen, right? Because of that some instances get changed, all that will happen. And also in this particular extracted UPF file, you will be having the power connectivity of that particular cells. That means from where the level shifter is getting the power and data, and to which particular pins it is connected to, which particular low voltage pins are connected to the power port VDDH or VDDL. Those particular information you will be finding in this extracted UPF file. So that's why you will be passing it to the PD engineer.
Okay.
Extra commands will be added here. That is required. Okay. The next is scanf. Will it be passed to PD engineer?
Yes, sir. Pass.
Scanf is passed to the PD engineer because they don't want the configuration setup. Okay, PD engineer don't want a configuration setup. They want is actual connectivity information. So that's why scanf is passed to the PD engineer. Next, DDC file, is it passed to the PD engineer?
No.
It's not passed to the PD engineer. So a DDC file is a compressed information. Okay, it is a compressed information of your netlist, libs, and your scan chain information if provided, plus UPF information also. Okay, what all information you have provided, okay, only logical information will be stored in this particular DDC. Okay, a compressed information of all the information provided in the tool so far. That is your netlist, library, scan chain, UPF, SDC, all that particular information will be stored over here. Okay, and this particular DDC file used only for analysis, used for manual analysis only. Whenever we see some violations, right? To analyze that particular violations, we restore that particular design information using this particular DDC file. Clear? Now,
Yes.
I'll just modify here. So now list the application variables which you have used for loading the logical libraries. So we are frequently saying, right, that providing the .db files, we need to provide that particular .db files before the compile. We are frequently saying that. Now, which particular variables are used for that? Application variables. Which application variables are used for providing the logical library information to the tool before optimization? Heard about link library, target library? Yes or no? Okay, so the most common used variables are to provide that particular logical library information to the tool is link library, target library. That means your standard cell DB, your global DB will be provided, sorry, standard cell macro related DB files and global DB files will be provided using this particular link library and target library only. Okay, whereas for synthetic library and symbolic library, instead of that space, if we give underscore, those will be the terms used. Target library, synthetic library, used for your designware components. Yeah, go ahead. Okay, the variables used for providing your standard cell and macro related information, timing information, is through this particular link library and target library. Okay, the designware components is provided using this particular synthetic library application variable. The schematic view of that particular to generate the schematic view of the design, the supporting symbols of that particular gates is provided using this particular symbolic library. So these two are auto generated. You don't need to provide it manually until and unless the tool is able to extract it. Okay, synthetic library and symbolic library are automatically getting generated. If it is not able to find it, then we need to provide it.
Like providing in the sense set link library one, something like that you're telling?
Correct. Yes. Set space link library space the list of files. List of libraries, or you can use this append. If there are libraries already set, right? So instead of removing those particular libraries, you can use this append as well. So either of that particular syntax can be used. Similarly, for target library and for your synthetic library, it will be the same process. Okay, clear? Now, moving to the next question, that is, which timing analysis and optimization is performed during synthesis?
Yes. Setup setup violation.
Sir, what about 11 number question?
Oh, sorry, I forgot. Yeah, I'll come to that because that is like finalized check that I will come to that 11th question. I think so. We are still having around 9 questions. We will complete those also, and then we'll come to the checks. Okay, which timing analysis and optimization is performed during the synthesis? So we have this like only setup analysis and sorry, there are two questions in between: timing analysis, and the second question is timing optimization, right? So timing optimization is done only for the setup and hold. Sorry, setup. Timing optimization is done only for the setup, but timing analysis is done for setup and hold. Why? Why analysis needs to be performed for hold in the synthesis but not optimized?
Because the
With
clock is
respect
not
to
propagated.
no. So with respect to timing constraint, our design is met or not, like setup is met or hold met. So before we are checking that.
Right. As first answer is like the clock is not propagated in the synthesis stage, or let's say the clock tree is not built in the synthesis stage, we are not going to be checking for the hold. Okay, first point. Okay, the tool is not going to be optimizing it for hold. Now the second answer is correct, that is like we are verifying whether there is any timing constraints disturbance for the violations. Okay, with respect to the provided constraints, the tool is going to be optimizing for the setup, and analyzation is going to be done for the both. Okay, first reason is clock tree is not built, so hold optimization will not be done. Second check is like analyzation for the hold to be done after synthesis stages, to make sure whether we have missed any exception with respect to hold, or any disturbance in the SDC file. So that needs to be checked with respect to the uh, analysis only. Okay, hold has to be analyzed only to verify the constraints is proper or not. Okay.
That means hold is analyzed with zero slack, assuming that clock is coming without delay.
Yes, ideal. Yeah, clock is
Yes,
ideal
it
only.
is reaching on time. So there is no.
So for example, there will be some cases where clock gating checks, we can say. There will be some timing paths to that particular clock gating. Okay, combinational cells. So in that particular combinational cells endpoint, do you want to analyze it for hold or not? That comes from the architecture. Okay, that comes from the architectural information, whether you want to check it or not. And let's say if I'm seeing a huge violation with respect to hold, okay, then what the tool will try to do it for the fix in the CTS stage? If I'm seeing in the synthesis stage itself a violation that we have the next itself, that I'm covering up now itself, If I'm seeing a huge violation in the hold during the synthesis stage itself, then how the tool is going to be fixing it in the CTS stage. Either by inserting more number of buffers in the arrival time or reducing the number of buffers in the required time, right? More delay buffers or more HVT flavored cells can be performed in that particular data path optimization. Yes, clock pulling has to be done with respect to capture, or clock pushing has to be done with respect to launch. So we are expecting is like more congestion to be performed. So whether that particular path is expected or not, that verification is what we are going to do here. No other cases, only analyzation. Okay. Now, coming to the 15th question, is DRVs optimized in synthesis?
Yes, sir.
Then which particular mode is used for optimizing this physical aware synthesis?
Mode
DRVs,
means
to fix this particular DRVs, which particular mode is going to be used to get an high accuracy?
Compile
option slow.
Right. So I'm not asking compile ultra or slow related terms. Okay. Physical aware synthesis. To be more specific, topographical mode is used. Okay. To get an high accuracy, physical aware synthesis is used for this particular DRV based optimization with an high accuracy. Even in the compile, that is in your logical aware synthesis also, this DRVs gets optimized. It's not like in the logical aware synthesis is not getting optimized, but in physical aware synthesis you will be having is an high accuracy, and as it is using topographical mode. Okay, my question is, if yes, tell me which mode is used for placing the cells. Okay, which mode is used for placing the cells? This is the type of synthesis, right? My question is
yes.
mode. So if I'm asking mode, topographical mode. Okay, and the type of synthesis is physical aware synthesis. Graphical mode,
Logic synthesis.
audible now? Am I audible?
Yes, yes, yes.
Okay. Power got off, so I need to switch to my telephone network. So in logical aware synthesis, you are going to be using is graphical mode or complete approximation, and used in logical aware synthesis. Okay, so this is what my question is. There are two answers. One is both are S only, topographical mode for physical aware synthesis and graphical mode for logical aware synthesis. Okay, now, so the next is like explain the flow performed by you in the tool. A quick flow. We have covered this particular question earlier.
Analyze, elaborate,
Yeah, correct. Analyze, elaborate.
compile,
Perfect. Next.
An insertion.
So there are two flows now. Okay, with scan chain insertion and without the scan chain insertion. Okay, whether your design may have scan chain or without scan chain, that is fine, no issues at all. Okay, with scan chain insertion means, sorry, without scan chain insertion means whatever you have said to me, that is correct. Analyze, elaborate, compile. Okay, and if it is with the scan chain, so I'll write down without scan chain. Okay, the steps are, now coming to the tool procedure, right? Okay, coming to the tool procedure, first is like, okay, first step is like setting the application variables, or you can say required application variables modification. Okay, modifying the required variables, that is like setting the logical libraries, that is sorry, link library, target library, synthetic library, symbolic library, setting all those particular variables, and also compile supporting variables, setting all or modifying those particular variables. Next, creating a project library. Okay, creating the project library with the technology information. Okay, and the reference libraries. Okay, next step is analyze, elaborate, and compile. Okay, this is without the scan chain insertion. And next is like saving, or let's say generating the outputs and inputs.
reports. Yes.
Similarly, with scan chain, after compile, you will be having one more step, or sorry, two steps. That is scan, providing the scan setup.tcl and incremental compile. Clear so far?
Yes, yes.
Right. So now moving to the next question, that is designware components. Now, how do you fix this particular designware components related linking errors? Which variable needs to be appended or updated?
Link libraries.
.sldb.
If you are having any design component, yeah, perfect. So those particular application variable, update the application variable. Which application variable? Which application variable? We have
Link
discussed
library.
previously.
Link.
We have discussed 4 types of variables earlier. From that, see the extensions and tell me which particular variable has to be appended.
Synthetic library, target library, no.
Hello, is it
Am I audible?
audible?
Am I audible now?
Yes, audible.
Okay. Repower and Wi-Fi got changed. Okay. So link library, target library, synthetic library, symbolic library. Which particular library needs to be appended?
Synthetic.
Right. So the variable which you need to update for the design where components is synthetic library. Okay. Now, similarly, if you are having the SRAM related, let's say any macro, okay, macro related information is missed, then which particular library variable has to be updated? If any macro or standard cell information related is missing, then which particular variable has to be appended or updated? Is the screen visible for everyone?
Yes, now it's easy.
Okay. Which particular variable has to be updated for this macro or standard cell related linking errors?
The synthetic library one.
No, the variable which you need to update here is link library. Okay,
Okay.
when you are having any macros or uh, standard cell linking errors, you need to update the link library. Okay,
Okay.
application variable
If library is
is
missed,
the
this link, yeah.
yes macros or standard cell linking errors. Now, similarly, I have is like now another case. Uh, a particular module, let's say a particular macro library is under development. Okay, a particular library is under development, and I don't find its equivalent DW cell also. Okay, and I don't find its DW instance. Now, can I perform synthesis?
Yes.
How?
The equivalent macro can be swapped. Earlier we discussed.
That's what I'm telling. I don't have its equivalent designware component. If you have a designware component, you can be able to swap it. If you're not
Okay.
having that particular designware component, then how are you going to solve it?
Make it
Maybe
as
we
black
can
box.
do.
Correct. Okay. Generating an empty module. That's what our friend is saying is like black box. Okay. A local hack we can say. Create an empty module. Okay. Create an empty module for this particular macro which is having the functionality miss. Okay. So that library miss, create an empty module and make sure while reading that particular list of files, this file is also read prior to it.
In that case, functionality will be incomplete, right?
Right, functionality will be incomplete. Functionality and timing information will not be known for this empty module or black box. Okay, but when it in this particular case, what will happen is like we want to store this particular optimization itself. So the boundary optimization for this particular empty module, we will try to stop only do the boundary. We don't go internal to that particular empty module. Okay, guys, just give me a minute. I'll be back. Just give me a minute. Okay, I'm back. Right. So here we were discussing, right? So generating an empty module. So with this as one of our present, we will be having functionality information or timing information will be not known for this particular module. When we are expecting, right? In let's say 10 days or 1 month, this particular module information will be provided. Then as a local hack, we will try to generate this and make sure it is not going to be splitting this particular module. Okay, ungrouping or merging of this particular module is not allowed. That is what we have to make sure. Otherwise the tool will try to remove it. We don't want that particular removal also. So we have to be very precautious while we are trying to perform this. Okay, we need to protect it. Again, there are some commands like set and group, and there are some other commands also which will be supporting for us to make sure like this particular instances are protected. Clear? Now coming to the next question, how can you say that a gate level netlist is a technology dependent file?
Because mapping will happen, right?
Right, mapping is going to be happening with respect to
Particular technology.
no. In let's say our netlist, if you are having an naming like in our RTL code, if you are having y equal to a and b, it will be converted to and 2x2 underscore hvt of a comma y, sorry, a comma b comma y. Like this, it is going to be converting, right? This is the below information is gate level netlist, and the above one is your RTL code. Now, how can you say this is a technology dependent file? So, simple answer is
Provide
go ahead. Huh?
provide cell name, sir. There is.
This particular cell name is your answer. Okay. So, the reason I'm going to tell you is during the optimization stage, based on the timing violations which is generated in the design, it is going to optimize it, right? That means for timing analyzation, the cell delays is required, the parasitic information is required, correct? So that
Yes.
varies with respect to technology, and also based on the vendor which is going to be providing you, based on the technology also, there might be change with respect to the cell namings also. That means in 28 nm you might find this like SAED 32 and gate LVT. When it comes to 14 nm, SAED 14 and gate LVT, and this particular and gate naming also might change. They just provide is like ND also. Okay, based on the technology, the first one is like the cell difference will have a change. Okay, the second difference is the parasitics will have a change, and the third difference is the naming of the instances will also change. That means the naming of the cells will also change. Okay, there are three differences. So based on the optimization which we provide as inputs, the tool will try to optimize it and give me. So that means the generated file will be giving me a better accuracy if I use the same technology libraries only. If let's say I have is like everything SAED 28 nm libraries in my netlist. Am I audible now?
Yes, now it
Okay.
is.
Okay. So let's say for example, I'm telling in from 28 nm to 14 nm, the only change is like the number. That means the instance cell name is having SAED 28 and gate, and in 14 nm it is SAED 14 and gate. If I change just 28 to 14, that particular netlist is 14 nm now. Yes or no?
Yes. Yes.
Right. But what about the timing? What about the timing? Will it be having an minimal mismatch, or there will be an heavy mismatch?
Heavy mismatch.
Heavy mismatch, right? So that means the netlist which I am trying to do in this particular methodology, I have to recompile it to get a very optimized netlist. Okay, so that's why we shouldn't do like this. Just for example, I gave you, but it should not be done like this. So how we are going to be saying that as a technology dependent file is, first point, okay, first point is map during optimization. During optimization, the instances, or let's say the cells, are mapped with the equivalent cells from the libraries.
During mapping or during optimization?
During optimization, the cells are mapped. Okay,
Okay.
there are
Okay.
two stages. Okay, first one, it will map it, as you said. The GTEC will be completely mapped with respect to your .lib. That is your first stage. Okay, again during optimization, the cell, if it is initially mapped with HVT, later on it will change it to LVT flavor or RVT flavor based on the timing violation, or increase of the flavor, increase of the drive strength, or reducing that particular drive strength. That is what I mean here. Okay, during the optimization, the cells are mapped with the equivalent cells from the libraries to get better timing. Okay, as the libraries are technology dependent, okay, as the libraries are technology dependent, so here comes your netlist is also technology dependent. Okay, technology dependent. Okay, if for example, okay, this is like, for example, as what I have explained earlier, if a gate level netlist is generated for 28 nm and trying to use in 14 nm or in any other technology node, we might see huge timing violations, congestion, power, everything. Okay, there will be a huge disturbance. Clear? So RTL code is technology independent. If you are changing the technology node, please re-perform synthesis. Clear for everyone? Any questions, any doubts? Can I move to the next question?
Yes, sir.
All right. So after synthesis, I am having an hold violation of 2ns. Then what are the possible reasons? What are the possible reasons?
Arrival time is less.
Arrival time is less. Right. Next.
Required time is more.
Obviously, yeah. Next.
Yes.
What is the reasons for arrival time is less or required time is more?
More number of buffers got inserted than the.
Here we don't have clock path optimization. So buffer addition in the clock path is not coming into the picture, right?
Okay.
More
More
cell delay.
netlist.
Combination path is more. Yes.
No,
Cell delay is more.
cell delay is more. Here our clock network is ideal, so cell delay also is not going to be playing a part.
Net length.
No combinational
Net.
path between.
In hold slack, high preference is like you will be seeing is like very less combinational path. Might be of 1 or 2 instances, or let's say very in rare cases you might be seeing is like more logic levels.
Logic
This
depth
answer,
is more.
sorry. So
This
first point,
combination
as you said, arrival time is less and required time is more. Okay, arrival time obviously it is going to be less because there are going to be having very less number of logics. Now coming to the required time is more. Now clock network is okay. What is the required time formula for your hold slack? Complete formula I want. Hold slack RT formula.
Whole time.
RT
This
RT hold is equal to
clock to queue delay plus combi delay
T capture plus time period.
RT is a whole time.
okay.
No, TC.
T capture.
Okay, T cap. Yeah, T launch. Yeah, T cap.
T capture plus T
Yes.
hold
And
plus I
uncertain.
heard one term called as time period. I'm not going to be mentioning it as a time period. I'm going to be mentioning it as T edge. At which particular edge of the clock the T launch or T capture is working. Okay, I'll just do one thing. 1 second.
Yeah,
I'll
same
write it in
edge.
common.
Yes.
I'll write it in common.
Okay.
Okay, so first point is 80. Whether it is setup slack or hold slack, I'm just going to be writing it in common. 80 is equal to T rise edge or fall edge plus T latency plus T launch plus T clock to queue plus T combo. Add the net delays also. Did I miss anything over here?
No.
Huh?
Margin.
Margin क्या होता है formula में? Okay, now coming to the RT, similarly T edge plus T latency plus T capture. Here with respect to setup or hold, plus or minus T setup or hold plus or minus T uncertainty. Right? This is the formula.
Yes.
Now here, when does an hold analysis be dependent on the time period?
If same clock, same rise it.
My question is, when does hold be dependent on the time period?
No. Only setup is dependent on time period.
Hold
After
is also dependent on the time period at certain situations.
Multiple cycle path.
Correct. Multi-cycle path. Okay, multi-cycle path or half cycle path cases. Okay, multi-cycle path cases or half cycle path, that is like
Sir,
integral
please
multiple
repeat, sir.
or half cycle. Okay, when your hold, your hold will be dependent on the time period if there is a missing multi-cycle path command, or if the path is an half cycle path. Okay, just try to look for this. One case is half cycle path. Second case is reg to reg or into reg, any timing path we have is setup MCP of 2 and hold MCP is missed. Okay, setup MCP of 2, 3, any number, and its hold MCP is missed. We will be having hold is depending on the time period. Okay, first is half cycle path. Second one is MCP for hold is missed. Okay, just try to look for this. Now, so the reasons are like half cycle path and MCP for hold is missed and setup is provided. Okay, these are the possible reasons for your hold violations. Okay, now what are the fixes? First is confirm with the designer. Okay, confirm with the designer whether this particular half cycle path is expected or not. Okay, the possible fixes are: first, confirm it with respect to the designer whether any kind of constraint fix has to be provided. Okay, confirm it with respect to the designer. Add the missing MCPs based on the confirmation from the designer. And the third fixes can be fixed in the CTS stage. Okay, and the third fixes can be fixed in the CTS stage by using manual clock tree algorithm. Okay, clear?
This manual clock tree, I'm not understanding.
So manual clock tree means you have to either perform a big buffer insertion instead of tool optimizing that particular path. You have to create that particular path by using a different type of buffers. Okay, now coming to the 22nd question. What are the possible reasons for your PNR? Sorry, if PNR is giving a feedback that he is seeing congestion and timing is not optimized.
Vishal, 21st is for hold, right? Till now we have discussed, not for setup.
One
Oh,
question
right.
missed there. That is for
Yes.
hold. Setup you missed.
Okay. I'll just reinvert. Because there are similar questions, so I just moved to 21 rather than telling about 20. I was discussing about 20 and I've written the answers in 21. Okay. Yeah, I'll go to 20. Now, after synthesis, observing setup violation of 2NS, then what are the possible violations? Earlier we have discussed for hold, but now coming to the setup, what are the possible violations for the setup NS which is of 2NS or random number?
High fan out.
Okay, so here again come with the same term, that is like RT is less and AT is more, correct? Setup slack violation means RT is less and AT is more. So I'll go back to my paint. So for AT increase means, okay, for AT increase means either this particular combinational delay to be high or this particular clock to Q delay should be high, correct? Yes or no? This is what we expect. So instead of telling like fan out high, check for the logic levels. Okay, check for logic levels in that particular path. If there are more logic levels in that particular path, ask for register cloning or logical restructuring. Okay, I'll just provide the fix also accordingly. If there are more logic levels, okay, there should be an RTL update to reduce it. Okay, or take the help of the tool itself to perform logical restructuring more. Okay, the performance here is logical restructuring. Okay, and okay, and the next solution is okay, and the next solution is make that particular path to see it has a more violated path. Okay, let's say you have to make that particular I forgot the term. Let's say like you have to make
Critical path.
yeah most critical path, and there is also one more term for that. I'll tell you the next time. Okay, I don't remember that exactly. Okay, most critical path by playing with the numbers. Playing with the numbers
Pipeline.
is like no, pipeline is another fix which to be provided by the RTL itself. That is a fix actually. I want is like the alternative term of critical also we have one term.
Timing
Okay,
sensitive.
I'll tell you that. Okay, the next is like modifying the values for uncertainty, derate, okay, uncertainty, derate values. Let's say when you make them complex, you will be the tool will try to optimize more. Okay, so that's why we will try to modify this particular uncertainty values, derate values, and weightage of path groups. Okay, this is all done in an iterative basis only. It's not fixed. Either one will give you a better result. Either by modifying the weightage of that particular group will try to fix the violation, or by modifying the derate it will give you a better result, or by modifying the uncertainty it will give you a better result. So it will always do in a parallel examples only, parallel iterations. Okay, it is not fixed. And the next is pipeline. Okay, pipeline is another fix to be done by the during the logical restructuring itself. Okay, pipelining is also a concept for the timing fixes to be provided. Okay, now the second is, okay, if logic levels are high, we are going to be performing all that. Okay, now there is also second most information, that is in certain situations you will be finding the edge of the clocks is equal. So we can say it has zero cycle path. Okay, generally we say zero cycle paths are for hold. Similarly, we have zero cycle paths for setup also. Okay, zero cycle paths for setup also is possible. There is no wrong in that. Okay, so if you're finding any zero cycle path, confirm it with respect to the designer. Okay, confirm with designer. And if he says that is expected, okay, and if he says that is expected, then the fix is manual clock tree. Okay, and the fix is manual clock tree. Clear so far? And the third possible violation, okay, and the third possible violation, that is, I'll create a new one. If I'm seeing, okay, if I'm seeing a path of this particular criteria, okay, that is launch edge is more and capture edge is less. Okay, there is an edge difference between the launch and capture. Okay, MCP mistake again. If I'm having MCP mistake, okay, if the launch edge is more and the capture edge is less, then how can I fix it? Launch rise edge is more and capture edge is less. That is, the possible cases are when you are having two different clock domains, clock 1, clock 2. Okay, when you are having two different clock domains, you are having is like launch edge is at an higher number compared to capture edge. So what we should do, again confirm with respect to the designer, and if he says that is expected and the path needs to be analyzed and optimized, then only with the help of manual clock tree we will be able to perform. Or if he says that is not expected, that particular path need not to be analyzed or optimized, timing exceptions has to be appended to be created, okay, in the SDC files. Is it clear?
Yeah, clear, sir.
Right. So I'll move to the 22nd. We are pending with the 11th question, I do remember. Okay. Now, 22nd question. If PNR engineer gives a feedback saying that congestion and timing is more, okay, there is an, let's say, from your result to his result for timing, there is a huge difference. Okay, there is a difference between your result to synthesized result to the PNR placement stage result. Then the possible reasons are, okay, then the possible reasons are logical restructuring is not performed well. Same like what we have discussed earlier itself. Okay, logical restructuring is not performed well. That means in my design, I am seeing complex circuits. Okay, like half adder, full adders are more. Okay, I want that to be simplified. Okay, I've meant by complex circuits are like full adder, off adder, and encoders, decoders, like that particular complex circuits are present. More complex circuits are present in one timing path. Okay, as I'm using in synthesis is like zero wire load model. Okay, for analyzation I prefer of using zero wire load model. I'll try to analyze on that only. Okay, on checking that I'm seeing less violations. But as it comes to PNR, there will be a parasitical information and transition changes, cell delays, everything will change. They will see it as a high violations. Okay, full adder, half adder, they will be having more delay values in the PNR compared to our particular design. So we need to simplify that particular circuits. That means full adder has to be converted to its equivalent AND gate OR gate based representations. Okay, not all, till you get a better result. Okay, so logical restructuring is not performed well. So because of that, you will be seeing is like more timing disturbancy. Okay, first point. The next is more number of cells added. Okay, during the timing optimization or during the DRV optimization, we are having is more number of cells got added here. Okay, as the tool is performing it, so sometimes it happens also. Irrespective of the congestion, the tool will try to insert that particular cells to fix the timing. Okay. Okay, so the solution is
Inverters?
yeah.
Okay.
So the fixes are okay. The fixes are first one. So to fix this particular logical restructuring, I want to make that particular path more critical. Okay, make the path more critical. Okay, to make
More
it more
weightage.
critical. Sorry, go ahead.
More weightage.
Right. To make it more critical, either by providing more uncertainty or derate, playing only with those particular numbers.
Okay.
Okay. Now, so make it more critical by modifying uncertainty, derate, path margins. Okay, either by using this particular methods, we can make that particular path more critical. The next is okay. The next concept is asking the RTL designer to reduce that concept. Okay, to reduce that particular logic depth. Logical restructuring using RTL designer. Clear?
Yes.
Right. So these are the two possible reasons for your timing. So the logical restructuring not performed well is also going to be leading your congestion violations. Okay, so that's why we prefer of doing this logical restructuring first and provide this particular netlist and provide this particular net list to the fix. Okay. So this particular practical flow we have discussed earlier.
Yes, logic and physical. Yes.
Practical flow we have discussed, right?
Yes.
So the remaining concept is SDC based. So that we will covering tomorrow.
Okay.
Right. Any questions you guys have so far? You can shoot.
Are you going to share this link?
Yeah, I'll ask for the admin to share
Yes.
this. I've shared him the link. I'm not sure whether how he's going to be representing it. Okay, he might create some link and he will be sharing you.
Hi Arjun.
Yeah, hello. Rudra
Yeah,
or Vishal, you can say.
hello.
Yeah, hello.
Yeah, Arjun, this is come to the 22nd question once.
Okay.
Actually, as per the PD wise, in the synthesis wise, we didn't get any congestion based on the cell, whatever the you told now. That is the
Yes.
logic is not
Restructuring.
performing well and more number of cells are added. Actually, as per the versions wise, previous versions we have the 1.9 m instant count, and the latest version is coded only for the 1.7 m million count. But we get the congestion in the PD, but it didn't get any congestion in the synthesis. What the reasons are you?
The reasons I'm saying here is in synthesis, you're not going to be checking for the congestion numbers and all.
Yeah, all
Only
already
during the
checked.
PNR you will be
Mm,
getting that particular congestion number.
mm,
So here what I'm trying to suggest you is, let's say in that particular timing path, if I'm having complex circuits like full adders or encoders, that means the
mm.
area count will be more. Let's multi-bit registers also will be having area more. The areas occupied by these complex circuits
Mm.
like multi-bit registers, full adders, half adders will be more compared to the basic circuits.
Okay.
Integral
But full and
multi-bit,
that one
it will
also will
be
get
too
in the
much, right?
congestion, right?
Yes, that will lead to the congestion mode.
Okay.
So
Based
sometimes
on
what
the
we will try
modules
to do
wise,
is,
okay.
uh,
Based on that modules wise, the cells are going to be placing the sitting places also getting the congestion, right?
yes, correct. If you are used any kind of bounds or any concept, then you will
Mm.
be having that particular congestion observed.
Why it's going to be unable to utilizing the more space? Actually, we if in case we have the empty space in particular corners, at the time also it's
Mhm.
not going to be utilizing. What is the main reason for that?
You are asking about PD related or synthesis
Yeah,
related?
PD related.
Okay, PD related, during that stage wise
Mm.
explanation, we will discuss that.
Yeah,
Okay.
okay, okay.
So currently
Thanks.
we are discussing about synthesis, that we will cover synthesis only, because if
Okay.
we touch PD, right, it will lead to
Mm.
multiple confusions.
Yes, yes.
That's why don't touch PD here when we are talking about synthesis. Don't link it.
Okay, okay, Arjun. Thank you.
Yeah. Any other questions?
Yeah, some sanity checks we missed. That 11th question.
Yeah. Yeah, 11th question, right? Okay, so as the time is up, we will do one thing. As we have one concept pending, right? SDC file. This SDC file and this particular sanity checks we will cover tomorrow.
Okay, okay.
Okay, such that there will be, because I can see like few people has dropped already. We will cover this tomorrow. Okay, right. Any other questions?
No question. Yeah.
Right. Okay, so this SDC based questions and this synthesis last sanity check, we will cover it tomorrow. Okay, thanks everyone.
One
Thank you.
question here.
Thank you.
Thank you, Arjun.
Thank you.
Thank you.
Hi Rudra, one question here.
Yeah, go ahead.
The flow of synthesis, sometime we call starting stage, translate stage something, or generic stage. Is it same as
Okay.
analyze and
Yeah.
elaborate?
Let's say like there are three categories like translating, mapping, optimization,
Yeah, yeah.
right? So analyze is different. So translating is similar to your elaborate stage.
Okay.
Okay, mapping and optimization will be done inside your compile stage itself.
Okay. Okay.
Right. So this analyze and elaborate, right? This can be executed by using a single command itself. That is by command called as read verilog or read file command. You can be able to perform in a single that elaborate. So translation also will be done to the tool understandable language. That's why we say it's like translation, mapping, and optimization.
Okay. Generic is also same term as translate, right?
Elaborate.
Elaborate. Okay.
Yeah. The elaborated netlist, we call it as like generic netlist.
Okay.
Independent of technology.
Okay. Got it.
Okay.
Thank you.
Yeah. Welcome. Okay. Yeah. Thank you, guys. Bye.
Yeah, bye.